So now we're in the part of the lesson where we get to use the more advanced version of graphing, the slope-intercept form, which is y equals mx plus b. But I want to take a quick moment to explain why this form works. Why is it that whatever the coefficient of x is, that's our slope, and whatever the number by itself is, that's our y-intercept? Well, the y-intercept part is super easy to explain because it gets back into when we were doing intercept earlier in this lesson. When we were looking at the y-intercept and saying, hey, the y-intercept is wherever the x value is 0, we can find the y value. So if we look at this equation here and we plug 0 in for x, we can see that the y value is just b. So this tells me that any time an equation is written in this form of y equals mx plus b, that the y-intercept is 0, comma b, or b is how far you're going to go up on the y-axis. And that's going to give you one ordered pair. Now, we could also look at plugging in an x value of 1, and let's see what happens when we do that. When I plug in an x value of 1, we get y equals m times 1 plus b, or m plus b. So what this is telling me is that when I run by 1, the y value, if this is m plus b, how much bigger is this second y value than the first? It's bigger by m. So this is saying when I run 1, let's rise by m. So if we take our rise and divide by the run, that's m divided by 1, or it's m. So this m value really is the slope. Whatever the coefficient of your x is, that's what we're going to rise by every time we run by 1. And so it's our rise over our run. And so that's just a brief explanation then of why this form works. Now we want to get into some examples and see how we're going to make it work. What are we actually going to use this for? The slope-intercept form is great for graphing. So if we're given this equation in y equals mx plus b form, the coefficient of the x is our slope. The number all by itself is the y-intercept. Now, if you remember, in order to graph any line, we need at least 2 ordered pairs, preferably more. This gets us an infinite number of ordered pairs. The y-intercept tells me where to start. It says start at 0, 2. Start at a y-intercept of 2. The slope of 2 over 1 says rise by 2 and run by 1. So from that ordered pair, we could go up 2 and over 1. And we could do that again, and again, and again, and again, as many times as we want. But the number 2 could also be thought of as negative 2 over negative 1. So we could also go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. And we can do that as much as we want too. And so we can see that we get an infinite number of ordered pairs. Now, one of the downsides of using this method, though, is that we're kind of putting all our eggs in one basket. We're saying, if I messed up on either the slope or the y-intercept, the whole thing is shot. That was one of the nice things about using point plotting, is when we found 3 ordered pairs, if they didn't line up, then we knew we made a mistake. If they did line up, we were pretty sure we did all right. So it's a good idea to check your answers on these as well. And a good way to check your answer is going to be to find a different ordered pair than your y-intercept. Pick any of them, like this guy here. This ordered pair is 2, 6. And try to plug that into the original equation of y equals 2x plus 2. Let's check if 2, 6 satisfies the equation, because that's what it means to be on the line, is that it makes the equation true. So let's plug 2 in for the x value and 6 in for the y value, and let's see what we get. So the fact that we get this true statement of 6 equals 6 tells me that I'm probably correct with this graph, because I have this ordered pair that I thought worked based on slope and intercept. When I plugged it in, it actually did work. That's good. If we would have got something like 6 equals 2, then we would know that that point should not be on a line, which means I made a mistake somewhere, and I want to go back and find my error. Let's look at this one. We got a negative slope on this one. And in this case, our slope is negative 3, and our y-intercept is positive 1. We always start at the y-intercept, so we're going to come over here to this positive 1 and start there. Now the slope of negative 3 can be thought of in one of two ways. We can either think about it as negative 3 over positive 1, or positive 3 over negative 1. In the first case, if we think about rise over run, then that's telling me to go down by 3, 1, 2, 3, but to go right by 1. And I could do that again if I wanted, down 3, right 1. Using the second variation, if I think about this in terms of rise over run, then it's saying that I can go up by 3, left by 1. And I can do that again if I want, and again. And when I connect the dots, this should be in line with what we talked about in the basics of slope. That this was a negative slope, it was a negative 3. And if we look back at that and say, well, what was negative slope? Oh, negative slope was decreasing. And if we look at this line, as you walk left to right down this line, you're going downhill, which means it is decreasing, which is what we wanted. Now I want to look at an equation that's not written in y equals mx plus b form. If we wanted to graph it, what are we going to do? Well, one option is to go back to point plotting and just to create an xy table and start picking x values and say, let's pick negative 2, negative 1, 0, 1, throw them in there and see what the y's are, and then graph it. Or we could say, hey, those two problems in the y equals mx plus b form, those were really easy. Let's do that. So we could take this equation and we could purposely write it in y equals mx plus b form so the problem becomes easier. So if we're looking at 4x plus 5y equals negative 10, the main idea of y equals mx plus b form is that you get the y by itself. So we're going to try to solve this equation for y. To do that, we're going to start off by subtracting 4x from each side. That's going to leave 5y on the left, and the right is negative 4x minus 10. Then to complete the y by itself, we're going to divide both sides by 5. On the right-hand side, when we're dividing both sides by 5, we got to think about that like distribution, that the 5 needs to go into both of them. So we get y equals negative 4/5 x minus 2. So if we look at that in y equals mx plus b form, then the slope is negative 4/5, and the y-intercept is negative 2. Remember, we start at the y-intercept, so we start at negative 2. And then for the slope of negative 4/5, we can think about that in one of two ways. We can think about it with the negative on the top or the negative on the bottom. And when we think about rise over run, a negative on the top means down. With the positive on the bottom means go to the right. So we're going to go down 4, but right 5. And we could do that again if we wanted. Down 4, right 5. There's another ordered pair. In terms of rise over run for the second option, a positive rise means to go up. A negative run means to go to the left. So we could go up by 4 to the left by 5. We could go up by 4, left by 5 again. And then we can connect the dots here. It's not the straightest line in the world, but I'm freehanding this. And then again, this should meet our basic idea of a negative slope as decreasing. This slope being 4/5 is a little bit less than 1, so it's a little bit more shallow than a 45-degree angle. And it does look like it's a little more shallow than a 45-degree angle. So we can be pretty good here. And then we can pick points and test them out as well. That if we want to pick, let's say, 5, -6, we could go back to the original, which is the best idea here, to test 5, -6. At which point we'd have 4 times 5 plus 5 times -6 is supposed to equal -10. That's 20 minus 30 equals -10, which is true. So we found an ordered pair, we plugged it in, and it works. That makes us comfortable and happy that this is the correct line.